Alright, the next thing we're going to do is go over some things with graphing. What I have done here already in red is what you should be able to do with your calculator. So what I'm going to do is go over some things that you'll need to know about the graph. For example, we're looking at a couple of things here where you're going to have to know the max number of turns in a polynomial. How do we know that? Well, we know that by looking at the degree of the polynomial. The degree is 4, so one less than that is the maximum number of turns. Also, we're going to have to know the real number of zeros, the number of real zeros. And again, the degree of the polynomial will tell you how many real zeros there are. Min and max are things that you're going to have to do with the calculator, and by now everyone knows how to do that, so we don't need to go over that. The one thing we should go over is the increasing and decreasing intervals. Okay, if we're looking at increasing, okay, what we're talking about is where does the graph go up? Where is this graph pointing upwards? Okay, so we're looking for x values. So we're looking for an x value from here, okay, which would be a little after 1, okay, and we already know that by one of the minima is 1.1. So it's increasing from 1.1 all the way out, okay. It's going to be increasing from 1.1 all the way up, because you see this is going up and up and up. Okay, so that's going to be positive infinity. Now, it's also increasing from the x value here till about here. Okay, so the x value on the minimum here is negative 1.3, and that takes us right up to the maximum with the x value of 0.2. Okay, again, this is increasing in this area here and increasing in this area here. So we're looking for the x values that pertains to. Okay, so let me just get rid of some of this stuff here. Okay, now the other area we're going to be looking for is decreasing. Okay, so again, we're talking about the x values where the graph is falling from left to right. Okay, so picture yourself starting on the left and walking the root of this polynomial. Okay, you'd be going downhill from here all the way up until you got about here. Okay, by downhill I mean if you were walking along, you'd be falling down, 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 all the way down until you got here. Okay, you get to the bottom, now you got to go uphill. Well, where was the x value at that bottom? Okay, so if we started all the way out at negative infinity, we would be falling until we got to that minimum x value of negative 1.3. Okay, then we'd be going uphill. Okay, so uphill until about here. And again, we'd be falling till about there. Okay, so we're going to be decreasing from the x value there, which is, what is that? It's a maximum of 0.2, and we're going to be falling until the minimum, which was at 1.1. Okay, so again, what we're looking at is where on the graph you're falling. So what we're talking about again is the x values, the x intervals. So just to go back over, where was it increasing? Right here. was one increase, and right here. Okay, picture from left to right. Well, where does that correspond to? That would be this x value, okay? Everything here and everything here, okay? Oh, and all the way over, okay? What's left in red is where the graph is falling, okay? The last thing I want to go over with in regards to the graph is the domain and range, okay? A lot of people sort of struggle with domain and range, which is understandable, but what we gotta just remember is what we're talking about. Domain is talking about your x values. What can x be? Okay, and what I always tell my students is start at 0. Okay, start at 0 and tell me if there's a y value for every x to the right of it. So if we're starting here, there's x values, x values, x values. Okay, and if I keep going all the way over, my x is just getting higher, higher, or my y is just going higher and higher and higher. Okay, and it's always going to get a little higher. So my domain is all positive numbers, and if you look to the left, it's going to be all negative numbers. So domain here is all real numbers. Okay, the range is going to be a little different. Okay, the range is going to be different because there are not the graph doesn't cover all the y values. Okay, so let's just think about range for a second. If you look above 0, there's a y value for pretty much everything. This is where one of the zeros is, this is where the other one is, and that arrow is just going to keep going up to positive infinity. Okay, but if you go the other way, okay, you come down to a point or a floor right about there. I have a nice crooked line there. But this y value, whatever this y value is, okay, is going to be part of your domain. Your range. Your range is a subset of values, and your range is going to be greater than or equal to whatever that y value is. So we found it already. One of our minimums was negative 3.5. So our range is going to be greater than, all values greater than negative 3.5. Right? One of the last things we wanted to go over was end behavior. End behavior was something that some people had trouble with, which is fine. Just remember a couple things. Number one, the degree here tells you pretty much everything you need to know. Okay, even degree tells us that that we have the direction of the end behavior is going to be going in the same direction. Okay, either up or down. In this case, the lead coefficient here is positive. It's positive 1. So our end behavior is going to be going up. Both the y values will be going up. As x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to positive infinity. Okay, so how do we write that? As x goes to positive infinity, y goes to positive infinity. That just means as x gets higher and higher and higher, y gets higher and higher and higher. As x goes to negative infinity, again, y goes to positive infinity. What does that mean? As your x's go down, 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 all the way to negative infinity, your y's just get higher and higher and higher. Okay, so that lead degree pretty much tells you the story. What we can do now is try to take a look at another one, looking at, let's see what we have. Okay, what we have is another polynomial here. We've got a lead degree of 5, so it's a degree 5, and the leading coefficient is positive, so our end behavior means it's going to be pointing down this way and pointing up that way. How do we write that? As x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. Okay? And again, we know this because of the degree is odd. It's an odd number. And the lead coefficient is positive. Let's try another one real quick. We will try, and this is a real good example. We have an even degree of positive 4, of 4. So we know that our end behavior is going in the same direction, and our lead coefficient is negative. So it means both end behaviors are going down. Okay, so how do we write that? As x goes to positive infinity, y goes to negative infinity. As x goes to negative infinity, y goes to negative infinity. Again, they're going in the same direction. So this is just a couple of things that you're going to have to remember how to do using the graphing function. A lot of this is done with your calculator, and after all of these things here are found, the rest is just sort of interpreting what you've found. So